Hello everybody, I'm Ruben Rodriguez and we're doing physics for grade 9 and 10. We're in chapter 4, motion and force. So let's begin. Force is an agent which produces or tends to produce or stops or tends to stop the motion of an object or a body. The unit of force is Newton, and 1 Newton is equals to 1 kilogram meter per second squared. Now, there are three laws of motion, and they were discovered by Sir Isaac Newton, so we named them Newton's law of motion. So Newton's first law of motion states that in the absence of a net force, a body at rest will remain at rest and a body in motion will continue to move in uniform speed in a straight line. The first law of motion is also called the law of inertia. Inertia is the property of a body due to which it resists against any change in its state of rest or of uniform motion. Now, here are a few examples of Newton's first law of motion. You can see that the object of rest will remain at rest. For example, in this case, you have a football. So unless an external force acts on it, it will move. Otherwise, uh, if no force is acting on it, it will remain where it is. So here you can see when an external force kicks the football, it moves and it continues to move, but it will only stop when an external force acts on it. In this case, there's a net that holds onto the ball. Now, Newton's first law of motion, as discussed earlier, is also called the law of inertia. An object will not change its motion unless acted on by an unbalanced force. Objects with a greater mass have more inertia, it takes more force to change the motion. Like for example, over here you can see that in order to move 300 kilogram of mass, more force is required as compared to pushing an object of 30 kilograms. Hello everybody, I'm Ruben Rodriguez and we're doing physics for grade 9 and 10. We're in chapter 4, motion and force. So let's begin. This is an example of the Newton's second law of motion. As you can see, the mass is constant, and when you push this trolley with less force, it will accelerate less, and if greater force is applied, it will accelerate more. Newton's second law of motion, uh, as you can see over here, the acceleration of an object depends on the mass of the object and the amount of force applied. So the greater the mass, the less will be the acceleration, and less mass will have greater acceleration. So it's inversely proportional. Acceleration is inversely proportional to mass. As you can see over here, uh, less force will be applied to move an object of lesser mass, and greater force will be applied to move an object of greater mass. So force is inversely proportional to mass as well. Now moving on to Newton's third law of motion. According to Newton's third law of motion, to every action there is an equal and opposite reaction, or we can say that action and reaction are always equal but opposite. So examples of Newton's third law of motion, you can see over here that a bullet fired from a gun, the bullet will accelerate since the mass is less, so it will accelerate faster as well as the recoil of the gun is less, and because the mass is more than that of a bullet. So for every action there is an equal and opposite reaction. So action and reaction are always equal but opposite. For example, when walking, your foot pushes the ground in the backward direction, and the floor pushes you in the forward direction. In the same way, boys' feet exert force on the boat, and the reaction would be that the boat exerts the same force on the feet. This is an example of Newton's second law of motion. As you can see, the mass is constant, and when you push this trolley with less force, it will accelerate less, and if greater force is applied, it will accelerate more. Now we move on to mass and weight. The mass of an object is a measure of the object's inertial property or the amount of matter in it. And weight of the object is the measure of the force exerted on the object by gravity. And the gravity, is the pull of gravity or the acceleration to gravity has a fixed value that is 9.8 meter per second square, approximately 10 meter per second square. The difference between mass and weight is that mass is a scalar quantity, whereas weight is a vector quantity. Mass can be measured using an ordinary balance, but in order to calculate the weight, you need to measure it in a string balance. The unit of mass is kilogram, whereas the unit of weight is same as force, which is in Newton, because weight often is measured in Newton plus, and the unit of force is Newton. As discussed earlier, mass is a property of a matter. The mass of an object is same everywhere. The weight depends on the object of gravity. Weight varies according to location. This can be explained by example that the gravity on Earth is 9.8 meter per second square, and on Moon is 1.6 meter per second square. So if the mass is constant, 2 kilogram, so on Earth the weight will be more as compared to that on the Moon. Mass remains constant everywhere, and in space where there's no gravity, so the weight will be zero, using the formula W is equals to mg, where W is your weight, m is your mass, and g is your gravitational field strength or the acceleration of the gravity. Okay, in this topic we covered force and Newton's three laws of motion, as well as mass and weight and the difference between mass and weight. I hope you have understood. Hope to see you in the next lesson. Till then, take care.